5 programming paradigms. By the end of this chapter, you should be able to understanding of what is meant by a programming paradigm. I will tell you the meaning of paradigm in a little while. And then also, we will show understanding of the characteristics of a number of programming paradigms. So there are about 4 we are going to learn today. Low-level paradigm, imperative, object-oriented, and declarative. 4 of them. Programming paradigms. Fundamental style of programming. So it's a like paradigm is a typical example or pattern of some a model. Now we understand it's like the category of programs, right? The way the program solves a problem, not about the language itself, because languages, when you categorize, you have low level and high level languages. But these are the way the way problems are solved, they're categorized into paradigms or patterns or styles. Paradigms are supported by programming language features. So the different language features only cause these to be categorized under different paradigms. Some programming languages support more than one paradigm. So that is also there. You can't say this is just under this paradigm. Sometimes it might go into another one also, overflow into another paradigm, which supporting 2 paradigms. So again, the key term programming paradigm is a fundamental style of programming. Let's take the first one, low-level programming paradigm. Gives us the ability, contents of memory addresses and registers directly and exploit the architecture of a given processor. You will recall, we have done all these, isn't it? Manipulate the contents of memory addresses. There are contents, the instruction, the data, all are stored in memory addresses when a program is in execution. And registers, where do you have the registers? They are in the CPU. Along with what? What other things? Just to refresh your memory, a revision. The CU, ALU, and registers plus there's one more thing. What is that? The clock. And exploit the architecture of a given processor. So we know where the walls are, where the kitchen, where the rooms are, the architecture we know. We are not just the parlor or hall waiting for the waiter to come and serve, but we go into the kitchen and then exploit the architecture of a given processor. Means we go down to registers, memory addresses, that type of thing, and order our food to see, so to say, right? If we go to the kitchen bypassing the waiter, we can tell the chef, okay, I want that sauce and not the other. Can you add a little bit of this herb? I like that herb, and make it this hot or spicy or whatever. Exactly what you want, you can ask them. That is what low-level programming, as we learned, can do. And also, a given processor, remember, a processor has an instruction set. You remember? Instruction set. So Intel processor family, there are families like in the processor family, present in many PC type computers. That is, now it's called Windows computers, Windows and Mac. Earlier, PC type computer. They use the x86 instruction set. x86 instruction set. Then you have the imperative programming paradigm, another paradigm. There are sequence of explicit steps that are executed by the processor. Explicit is very clear and specific. Tells the computer how to get a desired result. In contrast to declarative programming, so there is something coming declarative programming lastly, the fourth paradigm we are learning. In contrast, that means opposite, or when compared to, it's quite different to declarative programming, where a program describes what the desired result should be. What should be the desired result? Here, how to get a desired result. How is under imperative and what is under declarative. Procedural programming paradigm belongs to the imperative programming paradigm. So procedural, another, you can say imperative and procedural are the same. In a way, it's true. Imperative programming paradigm. So that's why procedural programming paradigm belongs to the imperative programming paradigm. There are many imperative programming languages like Pascal, C, and BASIC. Just a few. There are many more. Now come printed programming paradigm. OOP, OOP, or OOP, or object-oriented programming paradigm. Based on objects interacting with one another, right? Fighting with each other, contacting, sending messages, objects. Objects are data structures with associated methods. So you see what objects are now? Data structures. We know that data structures, we learned a lot of data structures. In fact, ADT, that abstract data types, and using them we have data structures, the lists, the queues, linked lists, arrays, also all those things, data structures with associated methods. So connected. There are some methods or some actions connected to them or combined with these data structures. Those are all objects. Languages that were originally imperative, languages that were originally imperative, what we were thinking of earlier, have been developed further. They have been developed further to support the object-oriented programming paradigm. So originally what was there in the imperative paradigm, they have been developed more to come into this category. What is this category? Object-oriented programming paradigm. So what are they? Pascal, the name Delphi. So originally Pascal, which was under imperative, now further developed to become Delphi, which comes under object-oriented, or also called object. Visual Basic, originally Visual Basic under imperative programming, but the .NET version, the developed .NET version being the first fully object-oriented version. So that is also a bit of history. History, you must know. The first fully object-oriented version, of course, the Cambridge examiners will not ask that. But for general knowledge, it's good. Then Python and Java were designed to be object-oriented from the beginning. So they were from the beginning developed originally as object-oriented program, but Python and Java. And the last one, declarative programming paradigm. Programmer writes down in the language of logic a declarative specification that describes the situation of interest. Declarative specification, we declare what the problem is. So we tell what the problem is. Like earlier also we thought of it, what and how is the imperative and what is the declarative. What is the problem? Programmer doesn't tell the computer what to do. Doesn't tell what to do. Programmer poses a query or sets a goal. A query like inquiry or query, asking a question, or sets a goal. It's a goal for the program to achieve. It's up to the logic programming system to work out how to get the answer. So the declarations, there should be enough declarations how to get about with this and how to get the answer. Declarative programs are expressed as formal logic and computations are deductions from the formal logic state. Deduction, deduce like conclusions. Coming into conclusions like that. So computations are deductions from the formal logic statement. So using the formal logic statements, it comes to conclusions and gives the answer. Declarative programming languages include SQL and Prolog. Prolog is what will be doing in the last chapter. And SQL is coming under databases, structured query language. Structured query language. And that is the end of the chapter. A very, very short chapter. And the tasks also you have to do after chapter 26 to 29. After you have studied chapters 26 to 29, two tasks 25.01 and 25.02. That is, this is 25.01 and this is 25.02 to be done after. Now this we are doing right now is chapter 25. So after doing 26 to 29, 29 is the last chapter in the book. So once you finish the book, we'll have to come back here. So we have to make a note of it. 25.1 and 25.02. And there are no exam style questions either. We'll have to answer these as an assignment I'll give you. If you can't answer at once, you go through the recording, the book, and find the answers and submit the assignment. What is a programming paradigm? How many types of programming paradigms do you know? What are they? What programming languages give us the ability to manipulate the contents of memory addresses and registers directly and exploit the architecture of a given processor? What do you know about x86 instruction set? We learned all this. What type of program tells a computer how to get a desired result? Under what category? C and basic. With associated methods interact with one another. Give two examples of programming languages originally under a particular developed further to support another paradigm. Under which paradigm does the programmer pose a query or sets a goal? So all easy questions. I hope you enjoyed this video and as soon as possible, do the assignment and submit. So till then, good luck and bye.